In the name of Allah, the most merciful, the beneficent. My name is Kashaf. I am from Chemistry Department and my ID is 018. And my topic of presentation is drinking water testing. So why drinking water quality should be properly checked? The answer to this question is very simple. Ensure good health and quality. So if there is any change occurs in water quality, we have to monitor the water at fixed intervals from the same point of view. So drinking water quality should be checked properly to ensure good health. However, if it can also be a good idea to conduct water testing in response to an unexpected event such as chemical spill, water testing should be properly checked through. Now, there are many methods of testing water quality, and the first and the foremost step to determine water quality is its temperature testing. So the question arises, why we do temperature testing? We do temperature testing to determine the rate of biochemical reactions in an aquatic environment, and indeed, whether they are able to occur at all. And the second one, if the water temperature is too elevated, this can limit the water's ability to hold oxygen and to decrease organism capacity to resist particular pollutants. So for testing temperature, we just need thermometer, cold water sample, and a hot water sample. Firstly, we will see how to measure the temperature or how to test the quality of a water by using a temperature or by using a thermometer. Firstly, we will see for hot water sample how to test that water. Firstly, we will hold the thermometer in the cold water flow and we'll hold for 2 minutes. Then we record the temperature after 2 minutes. The temperature should be maximum of 50 degrees Celsius or above. If the temperature exceeds above 50 degrees Celsius, we will repeat the report and then take an action and above if it goes at above. For cold water sample, we will follow the same procedure. We will hold the thermometer in cold water and we will flow it for 2 minutes. Then we will record the temperature after 2 minutes and temperature should be of 20 degrees Celsius or below. If it exceeds above, we will report and take an action if it goes above this. The second test of water quality is pH testing. In pH testing, we measure the acidity and the basicity of the water. So most aquatic organisms are only able to survive within a pH range of 6 to 8. The apparatus for this pH testing is pH paper, water sample, and pH reagent liquid. There are two methods of measuring pH of the water sample. First method is by simply squeezing a few drops of pH perfect reagent liquid into small sample of the water. And then we will wait for the water to change its color. And then we compare the water color with the included pH scale chart to confirm pH level. The second method of checking the water quality is to fill up a clean container with test water. We will need to make sure that the water level is deep enough to cover the pH testing strips. Secondly, we will then dip out one of the test strip into the containers of water for a few seconds. The testing strip will change color momentarily. So once the strip has changed its color, we will then be able to find out the pH level. The pH testing strip would have been supplied with a pH color chart. Using this pH color chart, we will match up the color of the dip pH testing strip with the color on the chart to find out the pH level of the sample of the water. The third test is chloride test. Chloride test is usually present, chloride as we know that is usually present in fresh and salt water. However, its level can be accelerated as a result of mineral dissolving and industrial pollutions. The apparatus we use for chloride test includes digital calorimeter and a sample of the water. The procedure for this test is very simple. Firstly, we will add a DPT tablets or powder into a vial of sample water that causes a color changes to pink. Then we will insert this sample of the water that has pink color into a meter that reads the intensity of the color change by emitting a wavelength of liquid and automatically determining and displaying the color intensity. The range of the meter is 0 to 4 milligram per liter, and which is equivalent to 0 to 4 ppms. The fourth test is salinity test. Firstly, we should know what is salinity. Salinity is basically a measure of the content of the salt in soil or water, and it basically measures the total of the non-carbonate salt dissolved in the water. Measuring a groundwater salinity indicates how salty your topsoil may become of the vapor if the water table rises. The apparatus for this test includes salinity meter and a water sample, and the procedure is very simple. We just need a water salinity meter, and the water salinity is measured by passing an electric current between the two electrodes of a salinity meter in sample of the water. The electrical conductivity of water sample is influenced by the concentration and composition of dissolved salts. So salt increases the ability of the solution to conduct an electrical current. So a high salinity or high EC value indicates a high salinity level, and which means the water quality is better. The fifth test for water quality is dissolved oxygen test. It measures the amount of oxygen dissolved in water, and without this, aquatic life is unable to conduct cellular respiration, and is thus a key indicator of water health. The apparatus for testing dissolved oxygen is we need a diaphragm, galvanic electrode, and a sample of a water to test. The procedure for this test is very simple. A diaphragm with high oxygen permeability separates the electrodes and internal solution from the solution sample. So when the working electrodes and the counter electrodes are connected electronically, a current is generated by oxygen reduction. So this current is proportional to DO level. DO means dissolved oxygen. And the DO level can be calculated by measuring the current with an external ammeter. So while the working electrodes and the counter electrodes are connected electrically, a current is naturally generated because of the oxygen, and the oxygen in the internal solution is constantly a consumed state. So this method uses a high alkali solution like KOH as the internal solution and a hazardous heavy metal like lead as the counter electrodes. The sixth test for the water quality is turbidity test. And the turbidity test measures the amount of particulate matter that is suspended in the water, or more simply, how clear the water is. If high level of turbidity are present, photosynthesis is affected as light is unable to penetrate and increasing water temperature. So turbidity should ideally be kept below 1 NTU because of the recorded impact on disinfection. NTU is the unit which is used to measure the turbidity, or which is used to show the turbidity. The apparatus for turbidity test is an nephelometer and a water sample, and the procedure of this method is also very easy. Firstly, we to measure turbidity in a wide variety of sample with a nephelometer, which is also known as a turbidity meter, we just need a light and photo detector to measure light scatter from the sample and read out in units of the turbidity, such as nephelometric turbidity units, which is NTU, or formazine turbidity unit, FTU. The next is pesticide testing, and we measure whether any pesticides are present and their concentration level in water quality and how they disturb the water quality. The apparatus for this test is including swab and water sample, and the procedure involved. The procedure for the test is, so to test for pesticides, we simply passes a swab over the water sample and insert the swab into a detector and wait about for 30 seconds. A green light on the face of the device means the pesticides residue is under the EPA tolerance. Red light measures the opposite. Thank you. These all the references from where I have taken my material. Thank you so much.